Let's look at example 17. The tension in a stretched string of length 50 cm, mass 1 gram, is 100 Newton. When the string vibrates, determine the speed of the transverse waves traveling along the string, the fundamental frequency, the wavelength of the note, which is the second overtone, given that the speed of the sound in air is 350 meter per second. So we are given the value for the length here, 50 centimeter, the mass 1 gram, and the tension 100 Newton. And then first question, we want to find the speed, the value for V, and then the fundamental frequency, the value for F, and then the wavelength of the note, which is the second overtone, the value for lambda. Okay, so now let's write down the information that we are given. First is the length 50 centimeter. Let's convert to meter. Second is the mass, which is 1 gram. Okay, kita terus convert. Second is the mass, which is 1 gram. Kita terus convert kepada kg, 0.01 kg. And then the tension, 100 Newton. First question is the speed of the wave. So the speed of the wave, the value for V. Keluarkan formula, kita hanya ada satu saja formula for the speed of the wave, which is equal to the square root of T divided by mu. Di mana mu dekat sini adalah sama dengan mass divided by length. So here, boleh terus masukkanlah since kita ada mass. We are given the mass, the length is here, and also the tension is here. Kita boleh terus masukkan dalam formula 100 divided by mass divided by the length. So here you need to make sure that all of the value here are in SI unit because we want our speed in SI unit, which is meter per second. So tekan calculator and then you will get the speed is equal to 223.61 meter per second. Okay, second one, we want to find the fundamental frequency. Okay, we want to find the frequency for fundamental. Okay, you need to remember untuk fundamental, what is the value for the N? Okay, ni sangat penting lah. Kamu kenal pasti dahulu apa value for N untuk fundamental ni. So, value untuk frequency adalah Fn is equal to Nv divided by 2L. So, that's why we need to identify what is the value for the N for fundamental. Okay, fundamental frequency adalah sama dengan first harmonic. Nama lain dia adalah first harmonic. So, first harmonic N adalah sama dengan 1. So, F1 is equal to N adalah 1. V dekat sini adalah the speed of the wave here, which is equal to 223.61 divided by 2 length 0.5. So F1 is equal to 223.61 Hz. Okay, last one, we want to find the wavelength of the note. Okay, wavelength on the note, which is the second overtone. So we want to find the wavelength for the second overtone. Okay, kita tahu second overtone N adalah sama dengan 3. So, second overtone ni adalah sama dengan third harmonic. Okay, that's why kamu kena sentiasa berhati-hati nama yang digunakan dalam soalan. So, ada sesetengah soalan kita gunakan third harmonic, gunakan harmonic. Sesetengah lagi gunakan overtone. So, apabila overtone, okay, N tu 2 dekat sini kena tambah 1 lah. Okay, so in order to find the wavelength, we need to find the value for the frequency untuk third harmonic dahulu. So, F3 is equal to 3. Gunakan formula yang sama dekat sini. Dan V juga adalah value untuk the speed of the wave. 223.61 divided by 2 times 0.5. So value yang lain semua adalah constant. Yang berbeza adalah the value for the n here. So F3 is equal to 670.8 Hz. And now that we have F3, we can find the value for lambda using V is equal to F lambda. So this is what we want. And V dekat sini adalah the speed of the sound. Okay. Kena sentiasa ingat kalau kita gunakan this formula, the value for V is the speed of the sound. So the speed of the sound is given, which is 340 meter per second. Masukkan F adalah 670.8 and then lambda. So lambda is equal to 0.51 meter.